compression or data size and speed is very related. So how do we know how big is the database, the tabular database? If we go to the property, we get estimated size of 23 megabyte, which is wrong. If we are used to look into this into multidimensional in Tabular, we have to look into the dynamic management views, which are the views within the database that we have to run in order to get the information about. So that is something that not an every user would do. For that reason, there are tools like the one I will show you in Excel. It's called Vertipack Analyzer, that reads these queries, builds this model together, and provides us this information in Excel. And another such tool here is the one in the Power BI. Now, if we look into the information that we have, there are several Excel sheets, but the most important one is this one about the table size. It shows the total number of sizes of all tables is 2.5 billion bytes, and it is split into the data size and to the dictionary size. What we see here, that the cardinality of this table transaction, which is by far the biggest table, takes 99%, is 100 million, which is very bad for compression. We cannot expect good compression out of this. Now, going into the next level, we see the columns, and it tells us how much space each of these columns are using. Which just means if we remove these two columns, we will shrink the data size 20%. So the total data size in here is approximately 2.3 gigabyte, and dictionary actually it's very small. If we look into our example, that model of 100 million, this table takes about 63 gigabyte in disk space in Dynamics BC database. When we take this information into our data warehouse, then the size is 16 GB, shrinks 4 times, but there is no compression to be understood. So the reason for this shrinking database size is that we don't use all the columns, and that columns that we are using are structured differently. So if we look into the size of the data in the source, so these are all the columns in the source in the Business Central, then we can see there are total 52 columns, and in total string length, the length of all the columns together is in 1230 bytes. The problem is not that much in decimal and integer type, but in NVAR chart, because they are using like 80% of the whole record size. And although these are NVAR chart, the maximum size here is not always used. So in the real scenario that we have here, one record is 650 byte in size. Now we're looking into the size of the record in the data warehouse. Then we have big integer and decimal, which we are shrinking the precision from 3820, which takes 17 bytes, into 19.5, which takes 9 bytes. And what is very important, we do not have any NVAR chart, and we are replacing this with integers. Like, integers are replacing actually the whole model, which is like a star schema, because these integers are primary keys of dimensional table, which are acting like a dictionary for the transactional table. So the total size of one record is 150 bytes, which is shrinking the data 4 times. Shrinking data but not compressing it. Further, when we go, then we are applying, analysis services applying a compression, 6x compression, shrinking the data size to 2.3 gigabyte in a tabular database. And this is not so good. This compression is not good. We can expect easily 10 2050 or even 100x compression. So what we have learned so far, the most important part in memory usage compression and then also the speed of querying is number of columns, cardinality of each column, which means how many unique memory each column is. Lower the better, because the compression will be better. Data type, we can split date time into date and time, shrink the decimal precision and redesign the model. And on the fourth place, there is a number of the rows, which is somehow non-intuitive, but that is so. One more thing from development perspective, we have seen that file format in Tabular is JSON, and what is very nice structured light structured file. What is more important, that this model is nicely structured, where each object is presented its own hierarchy, and with this hierarchy and with this file format we can create or update any object within the model independently of other objects. What does it mean when we are programming changes in the model? We can update only one table, transactional or dimensional, or create or update only one measure.